All right, I think we can begin. I have 1 minute past 11, and this is Grzegorz Kiarszys from University of Szczecin.
And that's Mikolaj Kostyrko from Bamberg, University of Bamberg.
And we'll be having the pleasure of sharing this session for you today. Yeah, we're happy to see so many faces here, and I think we can begin. And we have also the pleasure to begin this session with the first paper, and we'll be discussing 2 case studies, and those 2 case studies will be an excuse to talk about. We'll be talking about 2 gaps that occur within the interpretation process while we are conducting our research with remote sensing data. And first, I'll be talking about the case study of First World War prisoners of war camp, which will be a case study to introduce the idea of parallax effect. I'll be also talking about parallax gap, and then Grzegorz will be also talking about survivorship bias and nuclear warhead depots.
So this first presentation is thought as a kind of small provocation, intellectual provocation, to make us not only show how we research things, but also how we interpret the data and what we do within this data and how we use it for creation of our narration. So, Mikolaj, to start.
Right. Yeah, thank you. Sorry. Just skip. All right. Just to give you a small context of what I'll be talking about, I'll be talking about a specific case study of a First World War camp that is now placed in Poland, that was built by the Germans during the First World War, and it was part of 180 or so prisoners of war camps built during the First World War. Nowadays in Poland we have around 30 of those sites, archaeological sites. Not all of them exist till this day and are possible to be researched with remote sensing means. And few of them are still visible or due to LiDAR data or aerial photography data, historical data, and so on. But only for a few of those sites we actually have good historical plans. So this is where also the archaeology comes in to show us how those places were built. Now, this is the case study I'm talking about, the kriegsgefangenen church, as it was called, and it's right here. It's number 23, and it's in the southern Pomerania. Now, what was our research question, right? Our research question was, how was the landscape built to perform the needs of the German soldiers who were keeping the prisoners here. So the question was, what kind of power relations were within this camp, right? And we were thinking power relations, and this is also, of course, correlated with where one can move, where one can't go, and, well, to put it simplistically, the performative of landscape, right? So we started with mapping this site with the LiDAR derivatives that we had with historical area photographs, and we've collected a big number of archaeological features, over 400 of them, and we had the feeling that we mapped what we were expecting, the plan of this camp, right? But it is hard, of course, not to notice that we are probably missing something, and we were missing something which we were actually hoping to achieve, to see how this landscape was lived, how they could have walked through it, and where they could have not, how the power relations were connected to how the landscape was designed, right? And well, of course, while we were investigating First World War or archaeology of the recent past, we have a lot of different sources which we can refer to. We have our prior knowledge. We know that how those places could have looked like. We have our expectations while we are conducting such researches. But then we have to also think how archaeology is constructed itself, right? And you can ask yourself if you'll be having this plan where you have lots of similar features put together and in a linear and in a nice way fitted, right? And if that would be an Iron Name site, what would be your answer? If you had only this kind of data that you'd be working on, right? Would you tell that it was a hierarchical or rather an egalitarian society, right? Of course, as I'm saying, we have lots of other types of data for historical archaeology which we can use. And here is a methodological tool which I'd like to introduce, something which is called a parallax effect. Now, the parallax effect is something that all of us actually, and most all the time, that we affect, that is implied upon us. And to put it shortly, you are introduced to a parallax effect if you look at your hand really close and you just close one of your eyes and then open the other one, that you see what is close to you from different dimensions, right? And by that you form a two and a half dimension. But where there is 2.5 dimensions, there's never 3 dimensions, right? So there's always a parallax gap, and this is something which I'll be also discussing. And you can also see the effect here on the left. But this is also used in photogrammetry, and here on this lower pictures, or the lowest photos, you can see a house which is being shot from the airplane from a different perspectives, right? Just like your eyes are focused in different positions and you're perceiving one point. But what we experience in archaeology while we are using different sources is also the time depth. So what we are saying here is that while combining different sources together in archaeology, we're constructing another dimension, right? This third or the and a half dimension, right? So within the photogrammetry, as we are used to it, there is always the time distance. It's really short, right? But in archaeology, we have to consider this time distance. And here we had the chance actually to apply further sources, like for example the postcards, which gave us glimpse towards the intimate lives of the prisoners and how they interacted with the German soldiers who were keeping them, and we were able to construct the borders of different parts of the camp, and through that we formed a little bit more towards our goal that we were hoping, right? The intimate, or rather the power relations within the camp, where we want to go, where we want to do. And here we're also able to apply a viewshed analysis, and it's something that if you walk through this landscape, you also notice that the camp was put in a place which was a little bit deeper in the ground or in the valley, and we've also corroborated this idea through the viewshed analysis, and you could notice that someone who would be standing in the middle of the northern part of the camp would have the feeling that he's actually in a closed area, and someone who would be walking to the city would not see what was actually happening inside it. Right. So what I'm saying is, and which I've already stressed as I think at this, is that within archaeological knowledge interpretation, we should first notice what we are achieving, and here we're talking about this another dimension, but then this what we are not achieving. So what I'm talking here is this parallax gap. So when we have those different dimensions, we are never having the whole picture set. So this analytical tool, which we're here proposing, is to focus on these parallax gaps that we should also have the focus on. Thank you, Mikolaj.
So the next example which was chosen by us to show that, or convince you that it is always worth to take inspiration from other sciences, not only what happens around archaeology, but also from mathematics, statistics. It sounds kind of obvious because we are at CAA conference anyway. And I will be referring to the term survivorship bias. The idea was known at least since the antiquity, so it's nothing new, but it was popularized within modern science by works of Abraham Wald. Abraham Wald was Hungarian Jew who got his PhD at Vienna University, And soon things started to go wrong, and there was an Anschluss of Austria, so Jews could not anymore work at the university, so he decided that he needs to move to the United States with part of his family. And when he moved there, soon war started, World War II, and a few years later, the United States joined the war, so he decided that he also needs to participate in the war effort, but not with a rifle in his hand or as an airplane pilot, but with the weapon he knew how to handle the best. Mathematics and statistics. And I know it sounds surprising, but it's also very inspiring. So at the time, he was before he was working for the Center for Naval Analysis. So he was working for later on for U.S. Navy. U.S. Navy analysts were making such documentation, and they were indicating all the bullet holes and damages that were seen at the aeroplanes that were coming back from sorties, from combat missions. And based on this documentation which was done, based on this data set, they were indicating a part of the craft that should be reinforced and additionally armored to ensure lowest loss rate. So the first decision that US analysts were making just before Abraham Wald came to work with them was very intuitive. They decided that they need to reinforce and arm the parts that bear the largest number of damage. And it did not happen because loss rate started to continue to grow. So they did not know how to explain that thing. And then Abraham Wald started to work for US Navy, and he asked one very simple but very important question. He asked, how do you think, where are all the aeroplanes with the bullet holes in the engines and pilot cockpit? And the answer is, they are at the bottom of the oceans. So they were never included in this record. And therefore the decision that was made at the beginning was wrong. And he said, what you should do is actually opposite to what you already did. You should reinforce the parts that bear no damage, because they are vital for the survival ship of the cruise and coming back from the mission. And it was done, and it actually helped to lower the loss rate. So right now probably you think how it relates to archaeology and the way we think in general about data sets and about survivorship bias. And I will try to show a very short case study to present you the idea how I use survivorship bias actually for the interpretation I do. So survivorship bias can be explained as a situation when we draw conclusions from the set of data which is incomplete, and we do not realize that it is in fact incomplete, and we never even ask if the data set is incomplete, you know. So conclusions may be wrong as well. The case study will be the nuclear bases I am researching, and later on I will have a full presentation about it, and right now I'll just refer to one of the examples. So for example, the spatial plan of those bases was unknown due to some historical circumstances, so I collected lots of data, remote sensing data, and laser scanning, the classified satellite imagery, aerial photographs, and I collected it and I reconstructed the spatial plan which allows us to interpret specific zones within the base. And for someone, for archaeologists who is focused on the facts, it may seem like my job was done here because I reconstructed what I expected. But that would be exactly thinking in the terms of survivorship bias, because there is much more to be told about this base than actually can be interpreted and seen within this image. So one day last year, it was July, I was walking through the forest at the base Podborsko 3001, one of those nuclear, tactical nuclear facilities, and I found a rubbish pit. And within this rubbish pit, there were some pieces of uniforms, things that I would expect at the rubbish pit within the nuclear base, but also some bottles, some cans, and child shoe, and some women boots and some plastic toys. So I did not know how to explain that situation, because when we usually think about how the base was organized and how was created the social microcosm within the base, we think that usually those bases were inhabited by young, very well trained soldiers who dreamed every day, every night actually. They dreamed about going to war and finishing the war in a spectacular nuclear fire. That's our imagination, and at the time I thought the same. I think it was very naive of me, and because I was thinking like that, I could not actually explain some of the artifacts from this rubbish pit. And later on, I met the guy, and this guy name is Mikolaj right now. He's my friend. He's ex-military. When he got retired, he was actually tank commander. When he got retired, he came back to his family village, started to be interested in the history of the region, and also in the history of the nuclear base at Podborsko. And he knows very well Russian, of course. So he did one thing probably archaeologists would not know. He registered at 2 Russian social media, Odnoklassniki and Vkontakte. Vkontakte is something like Facebook, but it's controlled by Russian government, and Vkontakte is like for Poland National Class or something like that. Anyway, and he started to look for soldiers who served at those bases and asking them for photographs. Soon he found those soldiers, and of course they never speak about restricted zone where the nuclear warheads were kept, because for them it's still a secret they promised to keep. But anything else, just ask. And just between some of those photographs was this one. And it looked like those little chaps had a great childhood living in the middle of the forest with their families. And just behind them, there are houses of NCOs that I know from the classified satellite imagery. Those were houses of non-commissioned officers. So what I saw at those photographs completely changed the way I interpret remote sensing data I collected, because I saw people of flesh and blood who had their little celebrations. Here is also the wall, a very symbolic, very meaningful way of separating the area where actually officers lived from the area where they worked. And I saw happy families, and of course, when you look at those photographs, it does, you are not anymore convinced that the dream of those people was to go to war and finishing our civilization. Of course, I'm also convinced that if the orders were issued, they would do their job. But certainly it's not about that. And I saw young soldiers who had their compulsory training, and just behind them, garages that I know from some aerial photographs, sometimes funny photographs. So what conclusions can be drawn from this example? The first conclusion is that the way we interpret the data requires of us referring not only to one sources, but thinking in the larger picture. The most difficult question that can be asked about scientists is not about what I see within the picture, because then, or data set, because it's relatively easy to learn how to interpret the data and how to, for example, vectorize archaeological features. Short training and you do it. But the most difficult question is to ask actually what I do not see in the image I created, what my data set lacks. And then the most difficult thing is also find the answer for that, because how can we answer for the question what my data set lacks if the answer is not within the data set? And then we of course have to start to think about methods we can fill in the gap. So that's the first thing, and I think this is the most important scientific and intellectual effort scientists can do. And the other conclusion is related to the answer why there were women and children within the nuclear bases. So the social microcosm was quite complicated when you think about that, and what was their purpose and what was their meaning. When you think about 160 young soldiers we put to the middle of the forest and tell them to look after a weapon of mass destruction, sooner or later something will start to go wrong, because they are alone in the middle of the forest, they are bored, so we'll start drinking or doing something, morale will go down, and there will be some accidents. So actually what Russian commanders thought was that the best way to control the situation is to create an illusion of everyday civilian life, and it can be achieved by putting officers and non-commissioned officers together with their families to this base, because believe me or not, nobody will control better the psychological state of man than his wife, of course. And that's what I wanted to say. And right now